So in the previous classes, we started discussing. We discussed about the first order and second order electrical circuits, right? So now, and after that, we discussed about the generalized second order systems or generalized systems. Okay? So we try to solve that. We try to solve so by using the differential equations, right? So now, so we found that so the solution or to obtain a solution from that, so it's a difficult one. So now what we have to do is we need to use the Laplace transformations, and we will apply Laplace transformations to solve these differential equations that we obtained from the electrical circuits, right? So next one is applications of applications of applications of Laplace transforms. So you might have studied this Laplace. So in the beginning of your mathematics course, right? So you are aware of these things, and I will not discuss the basics of what is Laplace and other things, right? Okay. So basically, this Laplace is known as S domain, right? So it is known as S domain, or this Laplace is the S domain equivalents, right? So now we have three electrical terms. So one is the resistor, another one is inductor, and we have capacitor. So how these elements, right? So how these elements can be transformed into Laplace, so that we will study now, right? So let us assume that, so this is the resistor and its voltage is V of t and its current is I of t. Similarly here also, its voltage is V of t and its current is I of t, and this one is and this current is I of t. All right. So what is the relation here? What is the volt? If you assume this is R here, so this is L and this is C. So what is the relation here? So V of t equal to R into I of t, right? So whereas here
V of t is equal to L di by dt.
so V of t equal to L into di by or di of t by dt. So what is the relation here for I of t?
C dv of
C into
dv by dt.
dv by dt.
dt. Right? So let's discuss one by one. Right. So if you apply Laplace, right? So what is the equation? So what you will get if you apply Laplace here? So what is V by T? So how can you represent with V by T? So it is V of S, right? Agree?
Yes, yes.
Okay. So it is R into I of S. You agree with this? Sir. R into I of S, right? So this equivalent circuit can be, so it will be something like this. And this is V of S. Okay. And this is current I of S. And this value is R. Understood? Right? So this is the Laplace equivalent for a resistor. So one side you have V of S, so that is voltage drop across the resistor, and the current is I of S, and its value is R. Right. In the same steps, right? In the same step, if you apply Laplace here, so what you will get? So what you will get here? So again, V of t is V of s, right? So L. So what is di of t by dt?
S into I of S.
So what is the function? For example, you have d by dx into f of x. So what is the Laplace for this?
S into capital F of S minus F of 0.
So s into capital F of
Cap
s minus
F of
this
0.
function f of 0 minus, right? Agree?
Sir, Fx F of S, no?
What is f of s?
S function in right side.
Oh, sorry, this is f of s. Yeah, correct. All right. S into f of s minus f. So what is this one? So what is this one? So this is obtained from the initial conditions, right? So this is obtained from the initial conditions, right? So here in the same manner, so what you will get here, if you assume that, so the inductor initial current, so we have some initial current, so which is I of 0 or I of 0 minus. So what you will get here? So S into I of s, right, minus I of 0 minus, right? Agree? Is this correct? Is this correct? L into S
Yes,
into
sir.
I of s minus I of 0 minus. So this can be written as S L into I of s minus L into I of 0, or 0 minus or 0 both are same, right? I of 0. Agree with this? So this is V of s. So V of s equal to S into L I of s minus some L into I of 0, right? So if you observe that, so this is something that is obtained by applying KVL in one loop, right? If you apply KVL, so here voltage here, so this is I of s, right? So this is I of s, you can write like this, right? SL into I of s minus some voltage drop or some voltage source. So how to designate so this into a closed circuit? So can we write like this? So you have V of s, right? So this is, you have inductor here, and this current is I of s. So what is the value of this inductor now? What is the value of this inductor? So this is I of s, right? So this drop, so this is the value, right? So what is the value of inductor in S domain? So it is S into L. Agree? Okay. And we have another one, so which is the voltage drop. So I will write here. Okay. So how to represent this one? So we can represent with some voltage source. And what is this value is L into I of 0 or I of 0 minus, more specifically if you want. So what is the polarity of this one? What is the polarity of this? Minus plus or plus minus?
Plus minus.
See here, if you apply KVL, So you're supposed to get this equation, right? If that is the case, so what if it is plus here? So now tell me what you will get here.
Minus plus.
Minus plus, right? Agree? So V of S, so this current I of S into SL, right? Minus of this voltage drop. Minus of this voltage drop. Understood? Is this clear? Is this clear? So
Yes,
that
sir.
means what you understood that, so we have an inductor and its voltage is V of t, right? And its current is I of t. So this value is L, and we have some initial current, so which is equal to I of 0 minus. So we have some initial current, so which is equal to I of 0 minus or I of 0, right? So this can be, so this is time domain, right? So what is its equivalent circuit in S domain? It's simple. So this now, so V of S. So this, what is the value here? So L will become S into L, and this current will become I of S, right? And what is this voltage? So that means this is I into 0 minus. Understood? Understood?
Yes, sir.
Okay. So this is time domain approach, and so how we are converting into S domain to apply the Laplace, right? So this is voltage source based approach. Similarly, right? So in this equation, so what is I of S? What is I of S? So what you will get if you apply I of S? So just divide this one with SL, right? So will it be V of S by SL, okay, plus I of 0 minus by, so what you will get here? So L gets cancelled, right? You will get with S, right? Is this correct?
Yes, sir.
Okay. Is this correct? I of S equal to V of S by SL plus I of 0 by S. Okay. Understood. So what you observed that, so this is I of S is equivalent to sum of these two currents. Sum of these two currents. Okay. These two currents. So what is V of S is voltage across the inductor. So how to write the equivalent circuit here? So how to write the equivalent circuit? So will it be something like this? So we have, this is I of S, right? So we have two elements here. So one is inductor in S domain. So what is the value here if this voltage is V of S? So what is the value here? So what is the value here? So we'll treat this as
SL.
SL, right? So what is the, what you left here? I of 0 by S. So how to represent this? So here this
Current source.
voltage, this drop we represented as a voltage source, right? So how to represent this?
Current
Yes,
source.
current source, right? So what is the polarity of this current source?
Downward, sir.
So what is the polar, downwards or upwards?
Downward.
So it will be downwards, right? So what is the value here? What is the value of that current source?
I naught minus
I not
I
minus.
I
zero
of
minus
0 by S.
Yes, sir.
Understood? It's very simple. So we have inductor in time domain, right? So that we can transform this into S domain into two ways, right? So one is voltage based approach and the KVL based approach and KCL based approach. So this is KVL based approach. So we have this voltage source here plus minus, okay? And this is also its equivalent, this current source approach. If you apply, right, so if you apply KCL at this node, right, so what you will get, this voltage is V of S, right? So this node voltage is V of S, so V of S by SL plus I of S by S, so which is equal to I of S. Understood? Understood. So we can straight away apply. So what is the current here? So in this element is no longer a inductor now. So this is no longer an inductor, just it's an element, right? So just it's an element. So represent that. So we represent as an inductor. That means it is earlier it is inductance. So that's why we are still using the same sign, okay, to identify that. All right. So now it is SL. What is the current here? So what is the current here? If you assume that this is the ground, so V of S by SL. So that is the current. Okay. So whatever the theories that we applied in DC circuits, right? So we can apply here. Understood? So how to represent the inductor in S domain? Clear? Any questions? So next we move forward to next one. So that is capacitor. So this is V of t and this is I of t, C, and it is having some initial voltage V0, or in other words V of 0 minus. All right. So how to write this one? So I of t equal to C into dV of 0 by, sorry, dV of t by dt, right? So how to write this in S domain? So if you apply Laplace, so what you will get? So tell me what you will get. So what you will get here?
I
This
of
one will
S.
be I of S, right? C into, so what you will get here?
S into V of S.
S into V of S
S into V of S
minus
Minus
V of
minus
0 minus
V of
0
0
minus.
minus. So this can be written as C, not C, S into C, V of S minus C into V of 0 minus. So which is equal to I of S. Right. So I of S, so one side you have incoming currents, right, equal to sum of two outgoing currents. Right. So what are their values? SC into V of S minus C into V of 0. So how to represent in an equivalent circuit here? So since it is I of S, right? So current based equivalent circuit. So how to write that one? Okay. So we have first element. So this is capacitor, right? And this value is V of S. So now it is plus minus, and this current is I of S, right? So this divided into two parts, right? So what is the value here? What is the value of this capacitor? So this node voltage is also V of S. So what is the value of that particular capacitor? This value. Hmm?
C V of 0 minus.
C, sir.
What is the value here?
SV SC sir.
S into
SC,
C, right?
sir. Yes, sir.
S into C. So how to represent this one? This component?
Sir,
How to
current
current
source.
source again, right? So what is the direction of that current source? What is the direction
Downwards.
of current source?
Upwards.
Upwards.
Upwards or downwards?
Upwards, sir.
Upwards, right? Right. So what is its value? C into
PV of
V of 0 minus. Understood? Understood. So it's
Yes, sir.
C now become S of S. So now if you apply KCL here, okay, so now this is the one. So I of S equal to V of S by SC. Okay, V of S into SC, you know the voltage, right? What is the current here? So, no, it will be. So what is the value here? So what is this value? If this is
1 by
X,
SC,
right?
sir.
See, it is simple thing. If it is some X, right? So what is the current that is flowing here? So V of S by X, right? So now what is X here?
1 by X.
So what is the value here? So it will be 1 by S into C, right? Okay. So then only the current will be equal to, so what is the current now? V of S by 1 by SC, so which is equal to SC into V of S. So this first term. And this is second term. So second term we represented as a voltage source, so current source. Understood? Understood?
Yes, sir.
Yes, sir.
So next, this is KCL based equivalent circuit. Similarly, we can write KVL based equivalent circuit. Right. So how to write that? So just extract this V of S. So what is V of S? In this equation, what is V of S? What is V of S?
I of S by SC plus V of
I
0
of
by
S by
SC
SC minus
plus, sir,
plus V of 0 minus by
0
how much
minus
it
by
is?
S.
S.
Yeah.
So what is the equivalent circuit here? It should form a, so this is V of S. Okay. So this is, first one is I of S into, right? So you have capacitor in S domain, right? So what is this is current is I of S, right? So what is the value here? So what is its value? What is that value? What is the
1 by
capacitor
SC.
value?
1 by SC.
1 by SC. Just simple. No confusion, nothing. So what is the source value here?
V of 0 minus by S.
P of
So it
0
will be
minus
V
by
of
S.
0 minus by S.
Yes.
So what is the polarity? So if you apply
Plus minus.
KCL, so this is I of S, right? So what is it will be plus minus.
Minus.
Just we are doing it in the opposite way. We know the equation, so we are trying to retrieve the circuit. Just simple, no confusion, right? So we know the equations, or we know the governing KVL or KCL, and we are just trying to interpret the circuit. Understood? So we can cross check here. So V of S equal to I of S into SC. So this capacitor, and this is V of 0 minus SC, right? So this is capacitor in S domain, right? So this is capacitor in S domain. So now we will treat this as a some DC element, right? So DC element. So still it is not, it's no longer a capacitor, but we are representing it as a capacitor because its origin is, this is derived from capacitor, right? So just to distinguish that. Understood? Right. So now what we understood that, so resistor is as it is. So in case of the capacitor, so capacitor now will become, so C will become 1 by SC. So if you have initial conditions, it will be like this, right? So these are the circuits. So for example, if you have no initial conditions here, if you know initial conditions here, so what is the change you will get here? There is no initial condition. That means I of 0 equal to 0. So what you will get here? So how this circuit will be modified if you have no initial conditions? So how inductor will be modified if you have no initial conditions? So this is time domain. This is S domain. Right. So what is the value here? So if there is no initial conditions, if I have 0, this is 0, right? So that means
Yes, sir.
so this entire thing is 0. So that means this is represented as a short circuit. So how what is the value here? It is only SL. Right. Similarly here, if it is in a current source based approach, so if I have 0 minus by S, I have 0 is 0. So that means this current source value is 0. Right. So that means there is no current source here. That means this current source is open circuited.
Open circuit.
So that means, so this can be SL if no initial conditions. Similarly for capacitor, so what you will get for capacitor? So what is here in case of capacitor? So here, if V of 0 is 0, right? So what you will get here, again this will be short circuited and this will be open circuited, right? So you left it only 1 by SC. So this will be only 1 by SC. Understood?
Yes, sir.
Okay. Thing is that, so only change it to V of S and this is I of S. So this is I of S and this will be V of S and this is I of T and it will be V of T, V of T and this is I of T. So that's all. So plus minus here. Right? Okay, understood. So with this theory, right, we'll try to solve or we'll try to apply to the circuits. Okay. So we have some circuit, something like this. So its value is U of T. So its value is 1 into U of T. If nothing is given, so 1 into U of D. So assume all initial conditions are 0. Find V naught of T for T greater than or equal to 0. In other words, find V naught of T. All right. If this question is asked to solve by using this is 1 Henry. If this question is asked to solve, so use the Laplace transform to obtain the equivalent set or to obtain the solution. So right. So how to start with this one? Right. So in this particular case, the initial conditions are given as 0, right? So initial conditions are given as 0. So how to approach this one? So we have convert this circuit into, so this is time domain circuit, right? So convert this circuit into S domain first. Convert this circuit into S domain. So how to do that? Right. So we have resistor. So resistor, we have no initial conditions, remember. So this will be the capacitor. That means capacitor will be replaced. So we have resistor, okay, and we have inductor here. So now tell me what is the value of this resistor in S domain? Here we forget to discuss this. If this is resistor here,
Same, sir.
what is this equivalent here? It will be same only, right? So there is no change. So it will be I of S. All right. So resistor, it will be same 1 ohm. So what is the capacitor here? How this capacitor will transform?
Three by S.
How this capacitor
3
will
by S.
transform?
Yes.
So what is the capacitor? If C is the capacitor, right? Its value is 1 by SC, right? So what is 1 by SC
Yes,
in this
sir.
particular case?
3 by S, sir.
3 by S. Sure. Yeah, 3 by S. So what is the resistor here? Again, it will be 5 ohm. So what is the inductor here? So what is inductor L? So it will be S into L.
S, sir.
So it will be 1 into L, right? So it is S only. Understood? Understood. So what is U of t? So what is the Laplace for U of t? So what is Laplace for U of t? U of t, so how to define this U of t? This is the one, right? So this value is 1. So what is the Laplace here?
1 by S.
1 by S.
1 by S, right? I think Sir has discussed this, I hope. Understood? For example, it is 10 into U of t. So what is its Laplace?
10 by S.
10
by S.
Just simple. Understood? So for example, 10 into U of t minus 2, what is its Laplace?
E to the power of minus 2S.
So 10 upon S minus 2.
10 upon, what is its value? S minus 2,
S
right?
minus 2.
Upon
So similarly, if it is 10 into u to the power of t plus 2, what is its value? 10 upon
1 by S plus.
s plus 2, right?
E to power minus 2 also present. E to the power plus 2 also present.
E to the power of,
U of t unit step function Laplace transforms e raised to minus s upon s. U of t of.
this is you saying minus 2.
Yes, sir.
Okay.
With
Anyway,
minus 2s.
2s.
Yes, sir.
Okay, anyway, we'll come back to this. Right now, it's not required. Okay. So this is the circuit, right? Understood? So what is the question that is given? What is the question that is given? Voltage across this T. So voltage across this T. Right. Somehow we need to obtain the differential equation. So for this voltage across this T. Right. Something in the form of s square, something at 1 by s square, something like that. We need to obtain that. Okay. Right. So there are several ways. There are several ways to do that. So let us assume that our general method. Okay. So this is I1 of S. So this current is also in S domain, right? So now it will be V naught of S. Agree? So assume that this current is I2 of S. So now tell me what is V naught of S? What is V naught of S? What is V naught of S? if you know the current? Just simple question I ask.
-5 I2, yes.
So here, this is the voltage you required, right?
Yes, sir.
So this is the voltage you required. So you know the current is I2 of S, right? So what is V naught of S? Simple question. So will
I2
it be
of
S
Sir,
into
S.
I2
I2S
of
into
S?
S.
Agree?
Yes, sir.
Yes,
So
sir.
just don't confuse that. Just treat this capacitor or inductor just like a resistors. Okay, DC elements. That's all. Right. So just to identify, so the previous element is inductor or the previous element is capacitor, just by denoted with this capacitor as capacitor. That's the reason. And we changed it as 3 by S. Understood? So this will be S
Yes,
into I2 of S. So that is the voltage across this capacitor, right? So what we have to do is by using KVL, so we need to find I1, I2 values. So from that you can obtain the solution. Okay. So if you apply KVL in this first loop, loop 1, if you apply KVL, so what you will get? So what you will get here? If you apply KVL in this loop, what you will get? In this loop, if you apply KVL, what you will get? That is the question. So you have source here,
1
right?
by
So
S.
1 by S
sir.
equal to, so what is the drop in this resistor?
I1
I1.
of
I1 of S, right? Just I'm
yes,
writing instead of I1 of S, I'm just writing I1 just to avoid confusion, right?
yes,
So
sir.
I1 means I1 of S. So this is I1 plus,
3
right?
by
What
S
is
into
the other thing you'll get? 3
3 by
by
S into
S into I1, right?
I1 minus,
I1, sorry, minus I2.
minus I2
Minus I2.
also, sir.
Agree? So this is the first equation, right? So what is the second equation? So what is the second equation in this loop? So what you will get here? All our sources, 3 by S into I2 minus I1 plus 5 into I2 plus S into I2 equal to 0. Agree?
Yes, sir.
Agree? Right. Okay. So now we have to bring this equation in terms of I2, right? So what we have to do is we need to find out, so what is I1 value, right? So find out what is I1 value and substitute here. So we had two equations. Okay. So we had two equations. From that, you need to subtract the I1 value. So find out what is I1 in terms of I2. So what is I1 value? So what is the value of I1?
Sir, 1 plus 3 I2 upon S plus 3.
1 by 3.
No, sir. So 1 plus 3 I2 upon S plus 3.
No, we have another equation is there, right? What is that equation? 3 by S, I1 minus I2, okay, plus, so what are the other terms you have?
I1 equal to 1 by S.
5 I2 plus, what is the second equation? 5 I2
Plus
plus
SI2.
SI2 equal to 0, right?
Yes.
Okay.
Sir,
So
it is
separate
I2
this 3
minus
by
I1.
S into I1. Okay, 3 by S into I1 plus I2 terms what you have? So 5 plus S minus 3 by S into I2 equal to 0. Is this correct?
So shouldn't it be I2 minus I1 in the first
Yeah, it
one?
is I2 minus I1. Okay, so it will be, now what is, it will be minus I1. This will be plus now.
Yes, sir.
Okay. So now tell me what is the value of I1. We bring that I1 on the other side. So it will be 3 by S by 5 plus S plus 3 by S. Agree? Or I'm doing it wrong. Into I2. Is this correct?
Is reverse.
It is reverse now, sir.
It is reversed. Okay. So what you will get 1 by 3, right? So that means S square, okay, plus 5S plus 3 into I2. I think just check it out. I think this is correct. Just check it out. So 5S square, so 1S will be get cancelled, right? Is this correct?
Yes, sir.
Okay. Right. So substitute this in the first equation. What is the first equation? So 1 by S. What is the first equation? 1 by S equal to I1. Okay. So I1, if you take it common, so 3 by S into 1 plus I1. Agree? Just minus 3 by S I2. This is the one, right? Just check it out. Is this correct? Or I'm doing it? No. Just check this.
Correct.
So I1 into, I hope this is correct.
Yes, sir.
Okay. So just substitute the value of I1. So it will be 1 by S. So I1 value will be I by 1 by 3 S square plus 5S plus 3 into 1 plus S by, so 1 plus 3 by S, okay, into I2 minus 3 by S into I2. Okay. So tell me what you will get. I think multiply with 3S. Multiplying with 3S or something. We have SS here, right? So multiply with 3S. So that gives you the proper answer, I guess. So what is the equation you will get? You just tell me. So what is the value of I2? So what you got? I2
Sir, 3 upon s cube plus 8s square plus 18s.
Say again, 3 upon
Sir,
what is
s
it?
cube plus
S
sir
cube
s cube
plus
plus 8s square
8s square
plus 18s.
18s. Just check it out. Is this correct or not? So I2 you got 3 by s cube plus 8s square plus 18s. Just check this one.
Yes, sir.
Okay.
Correct answer.
Yeah. So what you require? So V naught of S, right? So this is I2 of S. So which is V naught of S is I into I2 of S, right? So this is S into 3 by S cube plus 8S square plus 18S. So what you will get here? 3 by S square plus 8S plus 18. Okay. So V naught of S is 3 by S square plus 18 8S plus 18, right? So this is the one, right? So why we multiplied with S? So that we already discussed it, right? So voltage across the particular capacitor, it will be S times the I2 of particular inductor is S times the I2 of S. So what is the next step? What is the next step? Right. So you got these equations, right? So apply inverse Laplace. So apply inverse Laplace and tell me what is the answer. You're already familiar with this, right? So what you will get? So V of t. If this is its inverse Laplace, right? So what is the inverse Laplace of this one? What kind of form it will be?
Sir, can I see answer?
Yeah,
Sir, 3 by root 2 into e raised to
3 by
minus
root 2 e to the power of
minus 40 sine root 2
minus
t
4t
into
sine
sine root 2 t.
root 2t volts.
T. Yes, sir.
Okay. So how exactly solved here?
The denominator
How?
part make a perfect square.
Huh?
Denominator part make a perfect square.
Yeah, perfect square, right? So what you will get that if you do that?
S plus 4 whole square
S plus 4
2
whole square
plus
plus
root 2 square.
root 2 square. So what is the, you will get additional term. So 3, yeah, 3 is there, right? So root 2, so root 2 additional term, it means 3 by root 2.
So
No.
or multiply and divide by root 2.
Root 2 here. You are more familiar with this, right? So recently you are completed this course. You are aware of this, right? How to solve this? Hmm?
Yes, sir.
Okay, I think you are much more familiar than me. This is the way, right? So this can be written as 3 by 2.
Yes.
It is in the form of something like this, right? It is in the form of e to the power of, so we have e to the power of minus alpha t cos omega t. So what is its Laplace? So what is its
Plus
Laplace?
alpha. S plus alpha upon
No,
S plus
not this
alpha
one. No,
whole square.
not this one. E to the power of alpha into sine omega t. Sorry, sine omega t. So what is this one?
Omega upon
Omega
S plus
by
alpha.
s plus
S
alpha square plus
plus
Omega.
omega square. Okay, this is the one. Understood? Okay, so these equations we can simply solve by using the Laplace, so without having so much trouble. Okay. So try to solve. So one more. Yeah. So find V of t. Okay. So zero initial conditions. So zero initial conditions. So find U of t. Sorry, find V naught of t. Okay. What is the first step? So convert this circuit into its equivalent S domain, right? So convert this one. So it will be 1 by SC. So it will be S into L. So this is remains same. Okay. So do that. I will provide the answer. So it will be 40 into 1 minus e to the power of minus 2t minus 2 into t e to the power of minus 2t. Okay. Just try to solve this. Okay. You have any questions in today's class? Anyway, we'll discuss this in next class if you don't know the answer. Right. So any questions in today's class?